Yeah, thank you, Catherine, for the warm welcome. And thank you for inviting me and having me today to talk about some of the topics that we are very passionate about. Let me just share my screen, which hopefully should now be visible. No, damn, I need to move this. Okay. So I'm going to talk a bit about the work that we do here at the Berlin State Library in AI, and I'm gonna actually start, and I hope this is not too repetitive for some of you, with a brief introduction to AI, because we here in my team and at the library, we have some views on this. And to get me started, basically, a key point that we usually try to make is that already the term artificial intelligence can be seen as a bit problematic. So we usually try to avoid this in our communication, because talking of AI and as intelligence in a sense like it would be comparable to human beings is an anthropomorphism. So it kind of humanizes the technology and prescribes some values and attitudes that can be quite problematic. So according to our view, this is rather a good argument for sales and marketing pitches of AI companies. But if you look at it fact-based, it's rather not really the case. So we usually prefer to speak of machine learning just generally, or rather if we speak about neural networks specifically, about deep learning methods and technologies, which in fact are really stochastic prediction models. So they are massively determined by statistics. And if you want to be a bit more provocative, you could even call them, according to a very prominent paper by Emily Bender and others, stochastic parrots, because these kind of AI models, they basically act like parrots that repeat what they have listened to over and over again. But yeah, how does this AI work? Well, in principle, it's always the same. These models first need to be trained to really get some understanding of the tasks and problems that they should solve. And for this, they require large amounts of unseen data, or training data, as it's usually called. And this training data, it should really be pretty large scale, but it should also be very diverse, since these models pick up different clues from different input data. And therefore, the more broadly and diverse the training data is, the more the AI or the model can actually distill knowledge from or statistics from this input data. So that is a key factor, really, and this is already one of the main points that I want to make today, is that the quality of any model or AI really depends on what kind of data is actually being used to create or to train these models. Now, looking at the current situation with predominantly commercial AI, there are some issues with that. So we feel that there are some quite important questions currently unanswered, relating to these training data that were used to create AI models, and therefore really being problematic with regards to assessment of the quality of these AI models and their outputs. So for example, as you're probably aware, typically companies that are active in AI, they don't disclose what kind of training data they originally used to train their models. And therefore, it's also not really possible to access this data, check it, or kind of reproduce the effects of these models. Furthermore, there is very little being disclosed about, if at all, the quality assurance and selection criteria for these training data. I will come back to that later, but there is a quote in also a very prominent paper about the culture of data collection in machine learning, where a machine learning engineer says, well, if it's online, we ingest it. And this has been very much the anything goes principle of these companies. Another factor is quite often the data still needs to be prepared further. And by that, I mean, for example, annotated with tags or classifications, or somehow, enriched with additional information. And as far as we know, this is often outsourced to cheap labor countries, and there is not really transparent information about the individuals that are doing this work and what kind of guidelines, again, if any, are involved and used for those kinds of annotations. And last but not least, we probably already know of some examples of this as well. These models, they make mistakes, they hallucinate, and they contain biases. And it's usually not really clear how to report and rectify such problems and errors, because there's really no one to address them to. So that's a bit the background. Now, let me continue to give two quick examples to illustrate a bit better how really this training of the AI models works. So a very simple example from the computer vision domain, so trying to teach the computer to see, basically, is you want to train an AI model to distinguish pictures of apples from pictures of oranges. So how do you go about that? Well, you collect a large sample of pictures of oranges and apples, and you provide each picture with a label. This is an orange, this is an apple. And you continue showing these pictures to the AI, and you do that typically even in multiple iterations. And then eventually, if you have like enough diverse apples and oranges from different angles, different states of ripeness and colorings, the model should be able to correctly predict whether an image shows an apple or an orange also on any new and unseen data. So it has learned from these examples the characteristics that allow it to determine or to distinguish apples from oranges. Really simple. Very statistical process. A bit more complex is the case of the text processing models, or the so-called large language models that are the majority types of AI models that you're currently probably using if you're using AI, like ChatGPT, Gemini, and others. These models are trained on large amounts of text collections. And how does that work? Well, the model gets to see the same texts over and over, but typically there are individual words within these sentences masked from iteration to iteration. So are they basically removed, and there is an empty placeholder. And now the learning task for the model is to determine, based on the context of the sentence, what would be the correct word to replace the placeholder. So to give an example, if you would have the sentence, people like to go to libraries to read, and then there's the placeholder, the model gets asked the question like, why do people go to libraries? What would be the word that would fit best here? And then here you can see again how the model works. So based on all the other examples of text that the model has been shown, it will determine, based on statistics, which word is the most likely to be filled in the placeholder. And so in this case, one would probably get a result like people like going to libraries to read books. And this is purely determined from statistics, because in the context of libraries and reading and people going to the libraries, book is the most frequent and therefore the most likely word to be filled in for this placeholder. And in this way, the models basically learn to predict sentence after sentence by filling in word after word. So they don't really have any comprehension, but they basically build sentences and longer paragraphs of text by always determining, based on all the data that they have seen, what would be the next most likely word. So to wrap this up, one recent development, say in the last 1 to 2 years, is that these two modalities of image and text data are now more and more being joined in a common model. This is possible because in the model itself, all information and training that is distilled from it is actually represented as numbers. So any information from the pixels in the image, as well as any information about words and characters and texts, are to the AI just numbers. And therefore, you can kind of join these two information spaces of the visual and the text domain in a model by a purely mathematical representation. Now, one last slide before I wrap up this introduction. So this is a very simplified example of how this training of an AI works. And I guess many of you have seen such similar diagrams already. What we see here is basically a very simplified sketch of a neural network where you have these circles in 3 rows being neurons, or in the case of the technical AI model, matrix multiplications, so multiplications of numbers. And these are linked from one level to the next. So basically the information passes from the left side to the right side. And we see here basically 3 layers of so-called neurons. In reality, these models, and that's why they are called deep learning models, can contain hundreds or thousands such layers. And in fact, the current models also process the information bidirectionally. So once from the left to the right, and then again from the right to the left. But in this simplified example, we will just look at 3 layers and one direction. So what happens, I have, as I've just explained, I need to start with some training data where I have say, let's get back to the example of the apples and the oranges, an image of an apple as an input. And I already know the label. So what is an apple and what is an orange? And so when I show these pictures to the model, what it does is actually it breaks up the image of the apple into individual patches of pixels. And they can be even so small that we as humans cannot really find any meaning in them anymore. But the AI still does. And so the information gets processed through these different layers of neurons, where every time the neurons in the second level continue processing the information from the first neurons and then forward again their results to the next level and so on. And in the end, we get an output, a prediction of the model. And say, in the first instance, the model doesn't really understand what is an apple, and it falsely attributes this as being an orange. We know this output is wrong, so we can calculate the error at the right side. And in this case, since we know that the picture actually shows the apple, we say, no, you have to try again. In this case, it's actually an image of an orange. So what happens then is that these connectors between the neurons get shifted around. And thereby the flow of the information bits from the left to the right takes a different route. You can imagine it like a train track where basically you shift the rails to take another exit. And these changes in the way the information is being processed through the different layers of neurons can then alter the result of the prediction of the model. And we basically repeat this process over and over again until the model, for every training image that we've shown, always takes the right path to process the information so that in the end, the correct results get predicted. So what happens in this process is basically that the connections between the different information processing neurons get trained, which means they get assigned weights and formulas to perform their calculations. And this is in the end, when the model is fully trained, the result or the outcome of the training process, the AI or the model. It's a set of statistical calculations, and pathways how these calculations are being processed throughout the network. Right, so I hope this was somewhat digestible. Now let me turn to some more concrete examples to illustrate how we employ these technologies in our library setting. So first, let me just briefly share some words on the institution that I work for. So that's Staatsbibliothek zu Berlin, or Berlin State Library. So it's one of the state libraries of the 16 states of Germany, but it has a bit of a specific role since it's also part of a large foundation which includes also several museums, archives, and research institutes under the umbrella of one legal entity, the Prussian Cultural Heritage Foundation. The State Library is one of the largest institutions under the roof of the foundation, and it operates in two sites since we had the division of East and West Germany and East and West Berlin. So we still operate two sites, one in East Berlin, which is the historical building that you see on the top right, which has just been reopened a couple of years ago after a long period of renovation. And we have the modern building actually from the 60s, early 70s, which was in formerly West Germany. And this houses the modern collections, whereas the historical building houses the collections up to the 1900s. So the nice thing is we are open 7 days to the public, and there is a library access pass is free for everyone. We've been collecting also on a national level for about some 360 years, and amassed a collection of about 12 million books, which is one of the largest collections in Germany because, again, here the German history strikes. There wasn't a German national library until after World War II. So the current German National Library was only founded in 1949. And there are mainly just two big state libraries that formally have collections on a national level. That's the Berlin State Library and the Bavarian State Library in the south. So we operate our own digitization center, and we have currently digitized roughly 220,000 titles from our collections. So still lots to go there. What is quite nice in our institutions, we follow a public domain by default policies. So unless there are valid arguments to issue a more restrictive access, everything that we digitize, which is usually out of copyright, is published under a public domain license and free for use under any circumstance. We also use modern APIs like IIIF, and we have also a large amount of then digital assets in our repositories, which amount to roughly 7.5 petabytes or 7,500 terabytes at the moment. And since 2016, we also operate a library lab, the Stabi Lab, where we specifically provide prototypes of new technical developments, for example, from AI for experiments. We create data sets for reuse in the digital humanities, and we run events such as hackathons and transcribathons. Now AI, or as I prefer to call it, machine learning at Stabi Berlin also has quite a long history already. So we first started using machine learning in projects relating to OCR in 2016. And we've been quite successful in recent years also to get, again, national funding to really further develop and actually found a small unit here with my team where we work on these machine learning technologies in the cultural heritage setting. Currently, I have 9 people on my team, but full disclosure, we are all funded through third-party projects. So we depend on grants and according sponsorship. We do have 2 very expensive GPUs in our library, which is quite helpful if you want to make experiments without receiving huge bills from Amazon or other compute providers, but have the freedom to do some experimentation locally. And the main goal of our unit is to really research and develop open source technologies that can be shared in the community that are specifically adapted for the challenges of cultural heritage. And the main purpose is, of course, then to leverage these tools to provide better and more access to our digitized collections, basically following the agenda of the collections as data movement that has been established in the Anglo-Saxon world. Now, let me dive a bit more into the practical aspects. Basically, I will explain the whole workflow that we go about, and you will see that actually the use cases we have for AI are very much related to common activities in digitization as they have been, as they were already before AI hype started. And we don't really do any chatbots as such, but rather we employ these new technical developments in like traditional work and labor processes. So first of all, whenever you want to work with AI, you need to be aware that actually most of the work goes into the data preparation. Like I'm repeating myself, there is no AI, there's only good data. And then from that, you can maybe derive good machine learning models. So about 80% actually in our work, and this is the same as I know from other colleagues and groups, goes really into the data preparation. And this means like cleaning up metadata, enriching it with additional information sources, linking it to other information resources, and just homogenizing the data, and often also transforming it from, say, more library specific formats into data formats that are more suitable for machine learning. So for this, we developed some tools that convert, say, for example, typical library data formats into pandas data frames for Python, which are a very common tool and mechanism to work then with AI technologies. But what we really do as well, we basically receive images from the digitization department with very limited metadata, and that's where our process starts. So it's actually still the case that we need image enhancement operations and also image binarization for subsequent processing steps. Image binarization meaning transforming an image into a representation which contains only black and white pixels, where all the white pixels are background and all the black pixels are the foreground, the information and the content that you really want to extract. So as you can see in these examples, this can still be quite helpful, especially in historical documents, because you have these challenges that come from either storage or in this case, actually the ink bleeding through the paper. And then when these items become digitized, you see this shining through of the text from the adjacent page. And this is a big problem for the subsequent text processing and text recognition steps. So what we do here is, with the help of this binarization, we kind of remove these bleed through and shine through ink from the adjacent page so that only those letters and that content remains that we are actually interested in recognizing. Now, the next step, and this is where we are currently in my team investing a lot of effort with 2 developers working full time on this, is historical documents. And as you see in this example, especially newspapers can have incredibly complex layouts with a mixture of very different content types. So you don't have, say, just text, but you also have images, you have tables, you have sometimes ornaments, illustrations, diagrams, etc. And all these are important to understand the meaning and the relation of these content items and properly transfer them to the digital world. So the layout analysis, or segmentation as it's also often called, is one of the key steps in our digitization process. And here we see really that most of the AI tools that are currently available are absolutely lacking when it comes to historical content. The explanation is quite simple. The AI tools that are commercially available are typically trained on data that is available on the web. So that means modern contemporary documents in PDFs but they have rarely seen, say, a historical print from the 17th or 18th century. So all our experiments so far trying to correctly recognize these layouts in historical documents with modern AI models have been, well, not very successful. And we still see the need for our sector to actually involve and fill that gap. So we're developing here a tool that does this kind of segmentation, and it does this, as you can see in the second picture. This is what the AI actually sees. It looks at the image as pixel by pixel, and then it assigns values or classes to each of those pixels, depending on whether the pixel belongs to the background or to a header or to an image or, say, for example, a separator. And altogether, we distinguish 10 classes, and some of these are very specific for historical books, say, for example, marginalia, which are these small notes that are written at the side of the page, or also initials or drop capitals, these huge illustrated characters that are often appearing at the start of a chapter. And yeah, both of these you cannot recognize with current commercial AI, so we're trying to build tailor-made solutions for that. As you can see here, we are also detecting the separators in yellow because they are very important in these multi-column documents to determine the correct sequence of the individual text bits. Because in the historical newspapers, sometimes the columns are very narrow, and it can happen if the separators are not detected that the text recognition joins two articles, and basically you end up in the result with what maybe be a correct text letter by letter and word for word, but it completely destroys the reading flow by merging basically the content within two articles, and we really want to avoid that. So as you can see here in this example, at the bottom of the page, we have in light green found an image, and this actually prompted us to do a small excursus from our work, because we found that actually so far our library has mainly invested into full text recognition, and basically any non-text information bits on the page were disregarded in the process. Now with this new layout analysis, we can actually determine with very high accuracy where there is graphical content on these pages, as for example in the image before. And then we basically cut out these images, and we use again here an AI model to index them according to their visual similarity. So this allows us to do something that you've probably also seen in other examples, or that you know from Google, to do an image-based search. So users can upload an image into our image search, and then based on the visual similarity on the pixels, the AI determines any similar images from our digitized collections. As you can see here in the example of the ship image, which is in the upper right, which was the input query. And then you see in the bottom all the several of the matching results that have been determined in our digitized collections. And this, for the first time ever, makes these images available for search. A nice benefit is now, since we have these multimodal models that I've mentioned, that we can actually combine the text and image search. So users can also submit a text query, as you can see here, a big ship entering a port, and the users still get a result set of matching images for that text description. So this is possible without any user or AI actually having assigned any tags or classification to the images about the content that is being shown there. It is purely based on the visual similarity of the pixels to the number representation for the text string in the multimodal model. So it happens on the fly, and there's zero effort for tagging or classification or creating metadata, which is quite nice. Now, continuing with the main purpose. So as I've said, a key aspect for us is text recognition. We have lots of content with these historical German fonts that until recently have been quite hard to recognize with OCR solutions. And fortunately, also due to various projects, we have very good open source solutions now specifically tuned for these historical fonts. And you can see here, I have an example of this small paragraph shown in the middle with the errors highlighted in red before we started developing the new OCR based on machine learning, and then the current result we achieve on the right. And we see that we've been able to reduce the errors down to one simple error, which we are really happy about. Now the benefit is, oops, I'm missing a slide here. Oops, okay, sorry. I'm gonna have to talk about that since I'm somehow missing the image here. The benefit of having high quality full text is that it then, of course, unlocks a multitude of use cases from the natural language processing domain. One very often requested one, and one that we've been actively developing, is named entity recognition and linking. So this enables to determine the names of, for example, persons and organizations or place names from the OCR full text automatically and link those to authority sources wherever available. So in our case, we use the Wikidata and the GND, which allows us, for example, then to determine, okay, is this Peter Meyer really this specific Peter Meyer in the text that belongs to this Wikidata ID and this Wikipedia article? Is the word Essen here referring to food, or is it referring to the place in North Rhine-Westphalia? And in the latter case, we can then enrich it with the geo coordinates. So this is very helpful since, again, it unlocks new possibilities for searching and analyzing the content and also linking it with other information sources. Right, so in all these processes, we create new digital assets and new data sets. And one aspect that we've also been focusing on is how can we provide these as data sets suitable to, again, then fuel new developments in the area of machine learning, which are then also maybe more suitable for these historical collection data. And we've started an initiative together with a working group of Europeana, the European Digital Library, where we've created a template based on a development from the former head of Google Ethical AI, Timnit Gebru, data sheets for data sets. And we've kind of adopted this approach and fine-tuned it again for the specifics of the cultural heritage sector. And there is a publication and a template that you can find on Zenodo, which describes this recommended standard that is now continuously being adopted, as we've seen by several institutions already, to properly describe data sets from the cultural heritage domain in order to really make them more attractive for the machine learning community to reuse and take up. Now, one of the aspects in these data sets that is specific in cultural heritage is that we enriched the former template with some fields that allow more contextualization of the data and also of the provenance of this data, because this is where we really see some big challenges. So let me now come to the final part of the talk and show some of these issues. So I've just mentioned already, one of the first issues, if we want to get our hands really dirty, is that already the data that we have and the metadata needs some additional work to really make it useful and apt for kind of machine learning work. So this, as I've said already before, often is like 80% of the work compared to the actual training and development of the AI model. And so here we really need also the involvement of the experts, our collection experts, to kind of, sometimes annotate, transcribe, or transform these data. Then, like I've also mentioned, and this is the case in many cultural heritage organizations, due to copyright laws, predominantly the historical collections get digitized. And here we have, especially in German-speaking countries, quite a lot of language variation in the past. And this makes it very difficult also, again, for modern AI tools to correctly reproduce the historical language in the digital. Whereas for us, it is absolutely key, given that most of our users are from the research domain, that we do not normalize or modernize, say, the historical spelling in an old book when we digitize it. Since, for example, there may be historical linguists that are interested in exactly this way of how the historical spelling has evolved over time. So it's a very high priority to not modify the original in any way when we transfer it to the digital. However, these are not usually use cases that commercial AI companies see much value in or opportunity for revenue. So again, this is a challenge that remains, I think, for the cultural sector to solve on ourselves. Even more important, these cultural artifacts have contexts that need to be taken into account when working with these materials and AI tools. So a very simple example here, the question Berlin is the capital of has completely different answers if you look at these different time periods. So how can we teach the model to distinguish these time periods in cultural contexts? How can we create chronosensitive or diachronical AI models? This is still an open question. Also extremely important are ethical and social or legal issues that we find in the data. So for example, due to research interest, a majority of the documents that we digitize in our library comes from the colonial period or from the Nazi period. So we are, as I've said before, trying not to censor these materials. We put them online with a public domain license. But of course, we do not want to invite anyone to kind of just put this information, this data into a machine learning model and train, say, a racist, discriminative AI. You need to contextualize these data if you put it online, and you need to provide the expertise from curators, historians, and humanists to properly document these issues and make them transparent if you provide these data as potential data for machine learning purposes. And this is one of the bits that these datasheet templates that we've kind of developed together with Europeana pay a particular focus to. Now, last but not least, as you're probably also aware, to create or train such AI models, you require specific hardware, highly expensive GPUs that are often not even available on the market. And you require skills, personnel with the coding skills, which is quite hard to find also on the job market if you're competing with the salaries that AI companies and startups can provide. However, again, here, I think the cultural heritage sector has a benefit. We can pool resources and we collaborate. We share our results openly and we create open source. So I think there is a big opportunity for the cultural and the academic sector to really pool the resources and the expertise to create better and culturally sensitive and context-aware AI models. But this is a task that is very likely falling back on us. Now, 2 more slides. I also see, on the other hand, great opportunities for humanities and the cultural sector for contributing to better AI. So first of all, we've seen there are quite a number of use cases that we are now able to fulfill better with these machine learning technologies, and which opens up also new use cases, new search and browse facilities, and more opportunities also for research in computational or digital humanities. And secondly, and I think this is still very true, the cultural heritage collections that we maintain in our archives, museums, and libraries have been assembled over long periods of time by experts. So we currently still employ about 40 to 50 curators for specific subject domains that are very much in contact with their respective subject communities and domains. And they determine what is the information that is relevant enough, that is high quality enough to be added to our collections. So this kind of quality and selection criteria by relevance is already a big contribution from our sector that, as I said, is not really the case in the data collection practices in the AI community. So secondly, these experts that we have, they possess deep knowledge of the collections, the content, and also over longer periods of time. So we can and we should really try to leverage this knowledge of these human experts in these collections to improve the AI through, for example, reinforcement learning. There are techniques that can really benefit from involving these experts in creating better AI models. Generally, I think also, and this is a bit repetitive, I think cultural heritage organizations have a higher level of quality awareness and sensitivity when it comes to data management and data stewardship. And this is also, of course, since we are predominantly public institutions, state funded, and we are much more bound and actually also adhering to principles of transparency and respecting the intellectual property or personal data protection laws when it comes to using data and AI. And in that sense, I think there is a high quality of data management practice and taking this issue seriously and even over longer periods of time. So for example, when we create AI models, we do long-term preservation for them, we version them, we ensure reproducibility even of results that were created from past technologies. So these are all, I think, qualities of cultural heritage organizations that could really be leveraged for the AI domain. And there's basically this quote that I always put at the end of my talks, which summarizes everything I've said from a wonderful publication that I would very much recommend everyone to read. It's already a couple of years old, but it's still very up to date. Data and Is This Contents, which provides a survey of dataset development practices in machine learning and has some very shocking insights. And yeah, I'm not going to read this out, but this really summarizes, I think, the key aspects where we need to get more involvement of cultural heritage professionals in order to get more culturally aware and more context-sensitive AI models, which should lead to better AI for the general public and everyone. And so I'm going to end with this nice meme that a colleague from the Netherlands, David Kleisens, created. I think there is much more in it when we look at it, what can culture do for AI than what AI can do for culture. So let's get on it. Thank you very much. And now I would like to open the floor for your questions and discussion. You can still take a screen grab of the QR code where you can find the slides online, and then I will stop sharing in 3, 2, 1.
We have a question in the chat. And it says, so you are asked for NER and linking to Wikidata in the GND. From your experience, what entities do researchers look for? Persons and places probably are most interesting, right? And which are the runners-up?
Yeah, thank you for that question. So your intuition was very right. So we see, and this is actually predominantly the case for the newspapers, where we see actually the newspapers in our collection, digitized newspapers, see almost more users than, say, the other collections. And in the newspapers, names of persons and places are very often researched. I think there is some communities like genealogists, which are quite actively collecting and analyzing these newspapers to, for example, create family histories and family trees. People sometimes look just for fun for like historical articles about maybe family members or the places they were born or visiting. Yeah, generally also for the other collections, we see that this is a step, the named entity recognition and linking, that benefits several use cases. So to give you one more example, we've been working with digital humanists in history of medicine, who tried to recreate historical networks of pharmaceuticians. Sorry, I don't know the proper name. Doctors, nurses, and so on, by extracting this information through full text recognition and named entity recognition from historical source materials, and then creating, so to say, historical social networks for analysis to determine how certain information traveled, for example, between different communities, countries, groups, etc. So there is great potential, I think, in this step, and we see it now as a kind of mandatory enrichment for the digitized collections following the OCR, which we try to use for all materials that we digitize. And yeah, runner-ups. So at the moment, we're really looking at persons, locations, and organization names. But of course, organizations in a historical material are not as frequent as nowadays. We are also investing into event detection. That would be another kind of type of entity, if you want to call it that. Most other cases are like very project specific and typically bound to, say, a particularly scholarly research question.
Another question is what kind of pickup you're seeing from either the digital collections or the guides that you've created. Are you seeing these proliferate? Are you able to track where these are being picked up and utilized?
Yes, so at the moment, so especially with these data sheets for digital cultural heritage, we're quite happy to, so there is this Europeana working group, which is continuing to promote and create documentation and webinars for how to adopt these templates and guidelines. We know from at least two organizations in the Netherlands that have started to create these basically for all of their digital data sets. And we have an initiative here in Germany that is actually also kindly funded by the German Research Foundation, where we also try to integrate this into the digitization guidelines for organizations that receive funding for digitization from the German Research Foundation, which would then mean like adoption really by a large amount of cultural heritage organizations in Germany. And yeah, also Europeana has been considering making this their standard approach for data sets from the GLAN sector when specifically packaging it for machine learning use. So there is good adoption. It's still quite new. So I think we released the first template roughly a year ago, and there is now a version 2, which has some additions and also maps the template to DCUT, which allows for some better machine integration and interoperability. And yeah, we hope that it will continue to spread. Yes, Sigrun has a question, I think.
Yes, I do. Hi, thank you. Thanks a lot for all these explanations. I'm definitely not an expert on any of the technology, but as a manager, I'm wondering how you set up a process that actually works. You say that sometimes, of course, the data is already existing in many libraries, like if you have a large data set, but how does it work if, for example, we're digitizing as UN Library, United Nations Library, we're digitizing United Nations documents on a daily basis. And with that, we have like basic set of metadata only. So how would you start how would you integrate an AI tool, a training tool? Because I think that's the start, right? First, you need to train the tool on there. How would you start a process like that?
Yeah, it's a good, but also a bit tricky question. So, sorry, excuse me. So that was the cough still. As you see now, as I wanted to show what is, I think, quite specific in our case, we really employ these new technologies in processes that already existed beforehand. So it's all steps that we already had in the digitization process, where we just basically been replacing sometimes commercial, sometimes older technologies with these new developments based on machine learning. And we're kind of like, switching in and out different bits of the already existing pipeline there, which in my view is still like the most actually useful application, since sorry to say that I don't believe in all these kind of chatbot thingies, or I haven't really seen them contribute the kind of value or impact that they're being prescribed. Other than that, I think this is always what I say to colleagues who want to get into AI in our institution, like look at the use cases that you already have and really see if there is like an AI tool that could be leveraged for that, and then just try it. So I'm really kind of recommending getting the hands dirty and trying out different things and getting practical experience, and not shy away from even say ChatGPT and others, but really build up like competence by just trying how good it works. And then in our case, usually what we see, okay, it doesn't really work as good as we were being told or as we kind of expected. And then we kind of decide if we go into the process of actually fine-tuning or creating an own technology for that. And then usually what we do is we first start with creating an annotation or transcription environment, which then allows us to offer other staff members an easy way to create the training data, and also using their expertise in the collections to kind of get good training data. And sometimes we do that also in combination with academics. So we have some courses and seminars that we have jointly with members from the university here, where the students get some tasks to either transcribe or enrich data that we can then use for training machine learning tools. Sometimes we do these events in our lab, like the hackathons and transcribathons. And through all these different means, so to say, we try to create basically the fundament that then allows us to use this data to create or tune our own AI models. So it has a long tail, yeah.
Thank you already.
We have another question from the chat. You mentioned that you've lowered the error rate for vector recognition. How do you verify the accuracy of results? Do you still need to manually correct each document, or is there an automated quality control system now in place?
Very good questions. So this was one of the slides that unfortunately got skipped. So we've also been doing some work in like metrics and methods for quality assurance of text recognition. And the main way that is like scientifically accepted and established is to use ground truth. So that means you create accurate, like 100%, nearly 100% accurate transcriptions of a sample. Usually this happens by one or sometimes even more person keying a page. Sometimes it's two or more persons to really make sure that there are no errors by accident. And then you use these like correct intellectually manually created transcriptions as a reference to compare the results of the OCR and the automatic transcription processes. However, you can of course only do that for a very small scale. So you can do that only sample-based, since it's so much effort to create these ground truth resources. So what we are now currently adopting is an approach that I first seen by the National Library of the Netherlands. These OCR engines usually provide a kind of self-assessment score of their accuracy, which, as one would expect, is often quite optimistic. But what one can do is, with a small number of ground truth samples, one can determine if there is like a linear dependency, say, where the difference between the self-assessment of the OCR and the correct assessment that is being done by ground truth, if that is kind of a fixed difference, then we can basically once establish that using ground truth, and then basically predict the correctness of the text based on the self-assessment score by just calculating the difference between the self-assessment and the actual correctness, also for those pages where we do not have ground truth resources. And this, so far in our examples, has shown to be quite reliable. Another aspect that I would just like to briefly mention, because here there's also some discussion still in the research community in pattern recognition, computer vision, is to establish also good metrics for this kind of layout and structure analysis. So usually the QA methods look only at the accuracy of the text. And as I've mentioned before, there can happen process errors beforehand in the segmentation of the different content units. And for example, if the text of two articles gets merged into each other, those text accuracy metrics are not able to properly determine this. So we need additional metrics that are also taking into account the structure recognition of the document. And this is still an open question also in the pattern recognition community.
We have another question in the chat, which might be the last one we have time for. It says, could you elaborate on your proposal that domain experts in library subject departments can bring their knowledge for improving the artificial intelligence or machine learning, especially based on digitized material from the collection? And it mentions old bibliographic metadata can be sparse.
Yes. So indeed, so this is a bit what I said before. So we try usually then for most of these use cases that are shown to involve the experts from the different departments in our library to create these training data, which means we provide them with tools that make it kind of convenient and quick to transcribe documents or to annotate certain segments of the documents. We've recently created an environment where colleagues from our historical prints department created training data for roughly 3,000 ornaments and printers marks, with the intention of then training an AI model from that data that is then able to classify printer marks, for example, automatically, to do provenance research, to determine the history of certain books based on how they moved, based on the print shops that they were originally created in. This would be one example. We also try, especially in these data sheets, to involve the curators from the relevant subject departments to really provide this kind of more rich contextual information about the provenance of the collections. Say, for example, for the users, it's quite often not very transparent why certain parts of the collection are available digitally and others not. This is sometimes driven by conservation reasons, sometimes by research interest, sometimes by the availability of funding. The quality and depth of the digitization varies from project to project, and trying to make that more transparent in these datasheet templates for the users has been something that we've seen much appreciation from the user community. So yeah, we try to get the colleagues involved as much as we can, also in order to give them a bit of a an understanding and confidence of working with AI, and at the same time not believing everything that the commercials tell them.
Well, looking at the time, I'm afraid this will probably be the end for today, but I would like to thank you very much, Clemens, for your presentation. It was very interesting and very informative and beneficial for everybody who was able to participate and to attend. I would like to also thank participants for joining us today, for your presence and for your questions. Clemens has already made the slides available. The link is in the chat. The recording will be available from the ALIS website along with the rest of the 2025 program and from our YouTube channel. So again, thank you all for your participation and your attendance today, and we look forward to seeing you at future Library Science Talks. Thank you.